Hi everyone. In this next example 14, we're finding something that we haven't found before, and that is the number of terms. Just a reminder that anytime we have a function, which is an equation with multiple variables in it, as long as we know all but one of those variables, we can calculate the remaining one. So as long as we have enough information, we can work out what n is. So reminding ourselves of the formula that we can use for n. Sn is n on 2 outside of 2 lots of t1 plus n minus 1 lots of d. We're going to use this formula as opposed to the other version, which is Sn equals n on 2 outside of t1 plus tn, because we don't know what tn is. We don't know how many terms we're including. We don't know what that last term is. So we need to use this version of the rule. Our sum to n terms is 8,533. Our first term is 5. Our difference is, we can see 5 plus 6 is 11. 11 plus 6 is 17, so our common difference is 6. We don't know what n is, that's what we're calculating. So we sub in those values into our equation. So it becomes 8,533 equals n on 2 times 2 lots of t1, which is 5, plus n minus 1 lots of d, which is 6. First thing I'm going to do is get rid of this 2 by multiplying both sides by 2 to get 17,066 equals 2 times 5 is the n stays there. 2 times 5 is 10, plus 6n minus 6, which gives us 10, n outside of 10 minus 6 is 4 plus 6n, and that's equal to 17,066. I'm going to expand the right-hand side to get 6n squared plus 4n. And I'm going to bring this 17,066 over by subtracting on both sides. Now we've got a quadratic that is equal to 0. So you can solve this a number of different ways. If you can factorize factors of 60 odd thousand, 120 odd thousand that add up to 4, then good luck to you. Otherwise, use equation solver, and to justify that, you simply write via equation solver, and you should find that n equals 53 or negative 53 2/3. You must write down both possible solutions. Then we state our condition. N has to be greater than 0, and n has to be an element of the integer set. Another way of writing that, by the way, is n has to be an element of the positive integer set. So that encapsulates both of these two things. Has to be greater than 0 and an integer, and we write that as the integer symbol with the plus on it. All right, so concluding over here, therefore n must equal 53. It can't equal a negative number, and it can't equal a mixed number. And our conclusion is 53 terms must be included. Question B is virtually identical to question A. T1 is negative 3. D is, we can see that this is plus 3, plus 3, plus 3, plus 3. So our common difference is 3. This time we're talking about a sum to n terms of 105, and we're trying to find n. We don't know what it is. So use a rule, write the rule. Sn is n on 2 outside of 2t1 plus n minus 1 lots of d, and then populate the rule. So sum to n terms is 105. N we don't know. 2 lots of t1, which is negative 3, plus n minus 1 lots of d, which is 3. Multiply by 2 to get rid of that 2, and we've got 210 equals n outside of 2 times 3 is negative 6, plus 3n minus 3, which gives us 210 equals n. Negative 6 minus 3 is minus 9, so it's 3n minus 9. Expand the bracket. N times 3n is 3n squared. N times minus 9 is minus 9n. And bring the 210 over. And we've got another quadratic. Again, don't factorise this via an algebraic method. If this happened to be on a non-calculator portion of a section, it would be something that you could solve without needing the calculator. This one is not, though, so we'll just go via equation solver. And we get n equals 10 or negative 7. We state our condition, but n is an element of the positive integer set. Therefore, n equals 10, and 10 elements or members must be included. And that's it.